All right, another thrilling episode of Tim Rambles on about things about wine. We're going to talk about wine finding agents. This one will be a little long, so if you want to go ahead and put this on a little bit accelerated speed, I have no problem with that. So one of the ideas that we have here with why do we find wine, and you guys are very familiar with bentonite because we had bentonite to take out protein, and that's a way to make a wine stable. But then there's some other things that we might do to improve sensory characteristics. So we had copper sulfate, which you look back on talking about how we worked on the Chardonnay to get rid of that furfural problem. And then there's some other things that we can work on, like carbon, which can strip all sorts of aromas out. But primarily what we want to look at in this lecture is to talk about how we alter the phenolic profile of the wine. So how do finding agents work? The idea is that we're going to throw something in the wine that's going to grab some other compound and precipitate it to the bottom of the tank. That's the idea, is we're going to take something that's bad in the wine or something we find objectionable. We're going to add something to the wine to grab that, and then it's going to settle to the bottom of the tank. So maybe we have some that are a chemical reaction, like copper sulfate with hydrogen sulfide. Then there are chemical reactions, physiochemical reactions that happen. There are some hydrophobic interactions, hydrogen bonding, electrostatic reactions. We're talking about that in terms of the proteinaceous finding agents that grab on to various compounds in the wine and precipitate them to the bottom. And that's primarily what we're going to talk about when we're modifying the tannins in the wine and the phenolics in the wine. And then there's mechanical, where we can take these finding agents, add them to the wine, and then strain out the compounds that have been made. So sometimes when we add finding agents, they'll connect with some of the phenolics, and in that process, they'll become too light to really sink into the bottom of the tank. But if we put them through a filter, the filter will catch them. So which finding agent do we want to use? Well, what do you want to achieve? Do you want to make a wine that smells like rotten eggs? Go away? Well, then you use copper. Do you want to make a wine that's too tannic? Go away? Well, then maybe you use a proteinaceous finding agent. Do you have a protein instability? Well, then maybe you use bentonite. So all of those things are finding agents, and what they're going to do is grab onto that objectionable compound and precipitate it to the bottom of the tank. And we have to think about, what's that sensory effect going to be? Because when we add bentonite, as much as that's nice to get rid of the protein, it's also going to get rid of aromas. There's going to be some negative results to that. And then also, if we add copper, that's great that we got rid of the hydrogen sulfide or the onion stinky aroma. But at the same time, we have to start thinking about, what is the other effect? So if we add copper, we may take out some of the thiols that are beautiful in Sauvignon Blanc, because those also react with copper. So the only way to do that is through a trial. And then after we do this, is the wine going to be stable? Are we going to create something that's tasty, but then going to fall apart within a few months? And then the other thing about all of these finding agents, no matter what they are, you're going to have some lees. You're going to have some excessive amount of lees, or not excessive, but some amount of lees. They're going to be made in the process. So in that idea that when you add these things, you're going to end up with a pile of something at the bottom of the tank that you may not be able to keep. And that's a loss, and that can be very expensive. So what we always have to think about is, what is the cost of doing this? Yeah, sure, it maybe makes the wine incrementally better, but does it really make it better enough to justify adding this? And does it, just the cost of the agent is one thing, but then the cost of the loss of wine. And most of the proteinaceous finding agents that we're going to talk about in this lecture create a pretty significant loss. So here's some finding agents. These are going to be the main ones that we talk about tonight. So we're going to talk about gelatin, casein, isinglass, and albumin. These are proteinaceous ones. These are ones that are made out of protein. And then there's some non-proteinaceous ones, and there's a couple you already know about on this list. You know about bentonite, and you also know about copper. So we'll talk about those in other right, but you already know about bentonite, and we'll talk about copper a little bit more in oxygen management, but we've already talked about how we can mitigate sulfide compounds with copper, but we'll get a little bit more into detail on that. But primarily, we're going to talk about carbon and PVPP. Colloidal silica is not really a finding agent, but what it does is that colloidal silica grabs onto all of these other proteinaceous finding agents like gelatin, casein, isinglass, egg, albumin, that when you put those in the wine, you'll go ahead and grab onto tannins, but colloidal silica is really heavy. And so what it does is it grabs any remaining proteins and pulls them to the bottom of the tank. And so that's why we really like colloidal silica, is that it's not that it's very neat on its own, but it really helps compact these proteinaceous finding agents to the bottom of the tank. The bottom one here is potassium ferricyanide, the K4 FeCN6. And what that is a compound that is available for removing excessive metal from your wine. So if you want to talk about potassium ferricyanide, the purpose of it is if you have a cellar hand that screws up and adds 5 times more copper to the wine than they're supposed to, you can remove that with potassium ferricyanide. The problem with potassium ferricyanide is it's not legal in the US at all. And you should never do it. Not that anybody ever doesn't do it. But if you have an excessive amount of metal in the wine, this reaction that happens, it's also called blue fining. And the only reason I'm telling you about this is there may come a time in your career when you have to do this and have to call somebody. And I'm sure you're going to be in Australia or Europe when it happens, because it'll never be legal in America. But we make wine in the rest of the world, so you have to be aware of it. That if someone adds 3, 4, 5 times the legal limit of copper to a wine, you can come back in and clean that up with potassium ferricyanide. And I'm not going to tell you how to do it, because the Australian Wine Research Institute, AWRI, has a fantastic page for that. And so go ahead and look that up and go for it. And if you ever have an issue with that, look up the AWRI and they will guide you right through that process. Detour ended. Okay, real quick, as I talk about the amount of stuff removed from the wines, we had raw product, we had raw wine, and so every enological product from manufacturer will have different purities for their finding agents. Always read the label. At the end of the day, always read the label. Always do a trial. Do not believe anything I say for a particular wine. It will always be different. And so every wine reacts differently to different finding agents. So all I want to tell you is always perform a trial. If you have a wine that's got something wrong with it and you think finding can fix it, perform a trial. All right, let's go ahead and move on to proteinaceous finding agents. So these are ones that are made out of protein. And you're very well aware of how all of these work, because you've looked in the bottom of your spit cup and seen these little like aggregate things floating around in the red wine bottom of the spit cup. Those are protein tannin complexes, and your saliva has lots of protein in it. So they're complexing with the tannins, and you've already seen this in action. There's nothing surprising about it. So the way they happen is, I'm going to go through this just for the fun of it, but there's some charge stuff where some stuff has a stronger charge than other stuff. So they just want to stick together. You got a positive and a negative, and opposites attract. That's the way it goes. Then there's also some hydrogen bonding that happens. And it's a fairly strong reaction. And those things bind together, and you will have a reaction between the tannin and the proteinaceous finding agent, and they'll precipitate pretty rapidly, and it's a pretty strong bond. And then there's also some hydrophobic interactions. And so hydrophobicity is a real thing, and that's a great word. If you can say it 5 times in a row, you're amazing. But these are fairly weak interactions, but basically you have tannins, which have a affinity for proteins more than they have an affinity for water. It's just like when you pour oil on top of water, there's a separation that happens. And most tannins are either lipophilic, and they'll prefer to stick to a protein source rather than to stay in suspension in water. So this is primarily what we're looking for. Even though it's a weak bond, this is what we're looking for, to grab the tannins and pull them out in these protein finding agents. So the isoelectric point, this is a point when a compound has neither no positive or negative charge. It's net neutral, it's in the middle. And the thing is that when proteins are at their isoelectric point, they will not migrate into an electrical field because their molecules carry an equal number of positive and negative charges. They're right in the middle. At a certain pH, the molecules of each protein fraction have an equal positive and negative charge. The wine proteins are the least soluble at this pH or isoelectric point. So what this means as that there is no difference between the charge of the protein you're putting in and the tannin you're trying to take out. So each individual fining agent may or may not work. And the only way to really do that in a real sense is to do trials. Honestly, we could go through the academic exercise of deciding the charge of the protein. We could do the academic exercise of figuring out exactly what target compound we're trying to remove. And then we could try to figure out how to add exactly the right amount. But that is never going to happen in a real winery scenario, given the technology we have today. So the reality is always do a trial because you never know what's going to happen. All right, so proteinaceous fining agents. The role is to interact with polyphenolic compounds in musts and wines to form insoluble complexes and precipitate from the wine, or also known as remove some tannins. And everyone's a compromise. So the reality is all of these start with a collagen. And so depending on each of the fining agents, where they start, where they go, collagen is broken down into smaller pieces that allow hydrogen bonding to happen. And that hydrogen bonding process is what allows tannins to connect with this and then precipitate to the bottom of the tank. I don't think we need to get too much more detail than that, but each of the fining agents has a different length and a different size to the collagen. So Isinglass has a different length than albumin, than casein, and gelatin. So they're all going to have a little different effects. So we'll go ahead and talk about how each one of them works a little differently. So when we start talking about gelatin, you're all very familiar with gelatin. I mean, you've had Jello. It's been around for a long time. And this is the good side to gelatin. I mean, who doesn't like a Jello shot? I mean, that does wonderful things. Now, before I move to the next couple of slides, I want to go ahead and preface that this set of slides that I made back in about 2011, 2012. But I thought that it was entertaining enough that it was at least worth leaving in. So most gelatin comes from, old bones. And this is a pretty stark picture of the way that it can be. But this is where we extract most gelatin that you would buy commercially to make Jello or other things in your house, foams or otherwise. And it's pretty surprising. But one of the things I found really amusing when I did this back in 2012 is this little meme right here. And I thought this was really remarkable because it was well before any of the other things happened. But anyway, I digress, but it is funny. However, as time has gone on, we've come to find out you can make lots of things from vegetables. So there's a lot of vegetable proteins out there. So we can make vegan wines, we can still use gelatins, and we can still have those effects from gelatin to fix a wine, but we don't necessarily have to use animal byproducts. And so we have a couple of examples from Lafort here. There are plenty of other wine companies that do it. These were the two fastest I could find, so I don't think I'm trying to promote Lafort. It's just that they're the ones I could find. And then the other picture there is actually from me. And this is an example of what $22 will buy you in Australia from their central market. And you wonder why we're all obese in America. All right, gelatin, this is generally how it's made. It's from breakdown of collagen and skin and bone with heat and acids. However, we obviously know that there are vegetable proteins available. And it's broken down, and the molecular weight can be hugely variable. And so every gelatin has a very different way that works on wine. Again, I want to get back to this idea of always trialing something. Okay, I thought it was really funny. I found this straight on the back of a manufacturer's label, and I had to cut it and paste it into here. But the quality of a gelatin is measured in bloom number, the measure of the strength of the gel formed in water. As bloom number increases, polyphenol binding increases. Bloom number ranges from 0 to 300, whatever that means. The ideal range for wine is 80 to 150. Who knows what that means? But it's measured by penetration of a rod into a gel. And you measure by the depth of that penetration in inches of the rod into the gel times the concentration in moles to get the bloom number. Yep, that's how they did it. Anyway, gelatin. It's clarify lees in white wine. That's one thing we can do, like flotation, which we'll talk about a little bit in oxygen management. To reduce browning in white wine, so if you get a white juice or something like that, you can add gelatin to it. You can use it to precipitate lees, and most importantly, you can use it to reduce astringency in red wine. Of note, it's the most aggressive proteinaceous fining agent. It clarifies and reduces brown coloration in white wines. It removes bitterness and astringency and everything. Can remove fruit character and everything. And will reduce the color of aged wines like high molecular weight phenolics like polymeric anthocyanins. It takes them away and is less effective on young wines. If used in conjunction with tannin or colloidal silica for sharper wine clarification. So the thing is, if you use gelatin, it doesn't settle well. So to flocculate it, to create a good flock, you really need to add colloidal silica. So basically what you want to do is add gelatin, add colloidal silica, and then go ahead and settle it out. This is a example that I found. It's actually from my master's program. So there's total tannin in milligrams liter, and then it was treated, and then we saw that tannin was reduced, but condensed tannins, these are polymeric anthocyanins, those were removed at a huge rate. So if you want to talk about a wine that had, pretty good character, but by the time you got done with it, you went up with a wine that was actually far more astringent by taking out a little bit of tannin. Pretty shocking in how that works. So I went ahead and took a look at this. And what we have here is this is Isinglass versus gelatin. So we tried a couple different kinds of gelatin. And one of them is Gelacol, which is actually colloidal silica. So it doesn't do anything or shouldn't do anything. And then we added Gelicom gelatin. And this was done by a student, A.G. Berglund. And he did a bunch of finding trials for us. And you can see that the gelatin just stripped the polymeric anthocyanins out. So the thing that gives us mouth-filling, soft flavor, the richness, the smoothness, ripped it right out. But at the same time, it took tannin down through the floor. So if you want something that's going to take a wine that's big and structured and turn it into nothing, gelatin can be your solution. Obviously, this was at a pretty big dose, but gelatin definitely can be quite aggressive. So the advantages of gelatin, they can be available in a whole bunch of different ways. You can buy them from different manufacturers with different strengths and different effectiveness. So there are variables. So don't consider my example to be perfect. I can removing browning effectively from white wine. So if you get a white wine that got brown because somebody didn't pay attention to it, you can go ahead and use gelatin to clean that up. And then you can also remove a whole bunch of everything because gelatin is the equal opportunity wine stripper. The disadvantages is boiled bones, but there are gelatin ones available. Variable results based on your trials. And then you can really strip wine. And I'd say it's not vegan, but yeah, it's not true. We've really got some vegan alternatives these days. Isinglass, on the other hand, is not vegan. This is a sturgeon. It is a giant fish, and I thought this was really fun. This was caught just outside of Seattle in 1907. So this is a sturgeon fish. It's a big bottom feeder, and occasionally you see some guy in a one-person kayak accidentally snagging a sturgeon and then getting pulled down the Columbia, which is always entertaining for everybody. But Isinglass is from the air bladder of a sturgeon fish. So it's derived from the collagen or the fibrous connective protein extracted from the swim bladder of usually a sturgeon. And how this came to be, I have no idea. It can have a fishy odor. It's got a pretty high molecular weight. It's pretty big. The reason why that's important is it's pretty big. So because it's such a big fining agent, it's not particularly aggressive. It targets medium-sized phenolics. And why that's important is Isinglass is really good in white wine for grabbing any of those little bits that just aren't quite settling right. But it's also really nice as something that could just come in and add a little bit of roundness, a little bit of, shape change to the phenolics. It's not too big, but it can take out a little bit of astringency with not a whole lot of effect on some of the smaller compounds and the bitterness. So where is it useful? Where is Isinglass useful? To polish red wine before bottling, to reduce astringency, and it's relatively safe to use because it's hard to overfine. You can't add a whole lot too much of it and completely strip a wine. If you add too much gelatin, you will strip a wine to the end. So here's another example. You can take a look at these in the PDF form, but not a whole lot of stuff removed. It's a pretty mild fining agent. It can remove some polymeric anthocyanins, but really doesn't take on a whole lot of tannin. And to be honest, here's a real example. And this is our 2012 Summit View Cab. And we see that the catechin kind of popped. And every time we do a finding trial, we sort of see that. And I think that's just it removing other things that normally were attached to catechin. And then polymeric anthocyanins drop a little bit and tannin drops a little bit. But for the most part, it's a very mild agent. One of the things I want to point out about making isinglass is it needs to be close to room temperature, slightly warm, resist the urge to heat it up, heat it and get it into solution. One thing I want to talk about isinglass is don't make a 5% solution. A 2.5% solution is all you get. You try to make a 5% solution of isinglass, you will end up with a clump of goo. So don't do too much isinglass water. Keep it simple, stupid. The upside to isinglass is gentler than gelatin or albumin. It doesn't have as great of effect on tannin. It flocculates easily, and it does not necessarily require a counterfine. You don't have to add gelatin to it. And again, I'll show you some pictures when we do our practical phenolic or fining lecture. The disadvantages: it's sturgeon bladder. It's variable results based on hydration temperature. So be really careful on how you hydrate it. And again, it's not vegan. All right. Albumin, egg whites. Somebody decided to commit suicide. Or eggicide, is it maybe? Or ovicide? I don't know what the right term is. From egg whites. Egg albumin is really simple. From egg whites. It's a globular protein. It's moderate in size. It is the most popular fining agent in the world. And we add a whole bunch of different rates of it from 0.02 to 1 gram per liter of egg white per liter. Each egg contains around 3 or 4 grams of albumin. And the thing is that's important with egg albumin is you always have to add a little sodium chloride, salt, or potassium chloride. And you need to add the albumin in order to kind of get the proteins broken down and able to work in your wine. So in this case, when you add some albumin, and this is one particular wine, we see that it removes a fair bit of, polymeric anthocyanins, which are the condensed tannins. But in terms of medium, tannins removed, it removes a bit, but it doesn't really do a very good job of taking out things like catechin. And so here we are taking a look at this guy. And this is what it did to our 2012 Summit View Cab. And it was fantastic at taking out polymeric anthocyanins. And it was also fantastic at taking out tannin. It was pretty good at stripping out. And I think this was a pretty aggressive fining agent. This is a fairly low pH wine. It was about 3.65. So it'll be really interesting to see how it works on a higher pH Cabernet. But leaving total anthocyanins alone and catechin alone. So again, those smaller phenolics didn't really touch. But in terms of tannin and polymeric anthocyanins, definitely reduced them. And so we see a wine that it would be much softer in every way, shape, and form. That's kind of always been interesting to me about egg whites, that we just add these sort of willy-nilly as a standard operating procedure to a lot of wines. So the advantages to albumin: it can be gentler than gelatin, but it's not necessarily as gentle as isinglass. It's really good at removing condensed tannins, which are polymeric anthocyanins. Is that good or bad? I don't know. They're easily obtained. You can go get them. Disadvantages: they're egg whites. Do you have an egg allergy? And they're not vegan. A variable source based on egg source. I mean, not every egg is the same. There's a long flocculation time. Take a month or two to settle out. You may want to add colloidal silica to settle them out. There's a potential for leaving soluble substance behind in the wine, some sort of egg, and if people are really allergic to it, do you want to make sure that they're drinking it? And again, it's not vegan. And what the heck do you do with all the egg yolks? So because of the nature of the beast, when you have all these egg whites that are being used in cultures where they automatically egg white fine, so in Bordeaux, one of the things I thought was really interesting was they have these things called quenelles. And I was speaking with different bakers and finding out the history. And these quenelles come from, they're an egg yolk based pastry, and they're considered kind of the pastry of Bordeaux. And the reason they end up making them is because of all these leftover egg yolks, because you don't want to let anything go. But in the wine, they use egg white fining as a standard operating procedure. It's as normal as topping the barrels, it's as normal as racking the wine. That what you do is you make the wine, then you add the egg whites, and it's just part of the process. It's part of the history. And so in these cultures, you have these leftover byproducts, which is the egg yolk, and you end up with these quenelles. And then also in some other regions, in Italy and things like that, where they did egg white fining, they have all these egg yolks left over. And I think they came up, this is where aioli and different things came from, because they're using these leftover products from production of wine in order to use them and consume them as a foodstuff. Just a picture of a cow with his head stuck in a dryer, completely cruel, messed up, but I thought it was a funny picture. So casein is basically skim milk. So it's a mixture of several proteins and dairy products. It's insoluble in acid, which is wine, and it's got a pretty low molecular weight, and it's useful in removing oxidative browning. So we're going to talk about that in red wine, but I'm going to tell you right now, the best way you can use casein in wine is for removing of browning in whites. There's a product called Vin Prieur Special, and it's amazing for removing little bits of browning. So if you get a white wine that's a little off, a little oxidized, turned a little brown, casein's really the best. And so you can really use straight up skim milk if you want instead of buying casein, but it does work really nicely. Again, it's fairly gentle in terms of its removal of product. It doesn't remove a whole lot. It's a little bit softer. It's not a really aggressive fining agent. And then here's our trial again. And again, we see that it actually didn't remove a whole lot, as barely touched anything. But we do see this catechin pop again, these small seed tannins, and I don't think that it necessarily is a pop. I think it's just a something else getting out of the way so we can read it. But again, very mild fining agent. So quick little slide here, not that I'm going to walk you through it, but here's a quick way to go ahead and calculate how you would use casein if you need to. I'm not going to expect any problems or math to this. This is for you to keep, and that it's someday if you have to find yourself doing a fining trial with casein, here's a good slide for you to use and go back to. So the upside is very gentle. Targets basically everything. It's easy to get. It's really great for oxidized white wines. Disadvantages, it's milk. If you're allergic to it, it's another issue. It doesn't flocculate well. It doesn't settle well. It commonly requires that counterfining agent. That counterfining is colloidal silica. So if you're going to do this, you add your proteinaceous fining agent, and then you come back with a little bit of colloidal silica a day or two later and help it settle down. So it's not vegan either. It's from milk. So if you're seeing a trend here, fining is kind of going out of fashion because we can manipulate phenolics on the front end with microx and everything else. But this is still important to note. But if you're looking to go to the broader consumer market where you're trying to talk about all the things that you're doing and you're trying to appeal to the broadest consumer base, these type of fining agents are definitely falling a bit out of favor. So here's a little chart for you talking about the comparison of aggressiveness. So gelatin is going to be the most aggressive for color removal and tannin removal and quantity of lees and tendency to overfine. So gelatin is the thing you pull out at the end when everything has gone wrong and you've got no choice. Obviously, there are more refined gelatins out there. There are better ways to take care of the problem, and they're getting better by the day. But traditional gelatin in the form of cooked down animal bones is definitely the super aggressive, which may be exactly what you want to do, because maybe you want to take some $2 a gallon bulk Cabernet and turn it into rosé, and gelatin will do that. Um, and so this is a little chart for if you want to target a particular thing, these are the ones you want to trial. It's not perfect. Of course, that isoelectric point matters. And so you'd have to try them out. But if you have a wine, you're working in a bulk winery, you're going to buy bulk wine, and you got to fix it up, fining agents can be very, very invaluable. If you're trying to take ultra premium wine and just fix it with these agents, you probably missed the boat. Okay, I want to talk about two more things. These are non-proteinaceous fining agents, and you're very well aware of one of these at least. So I want to talk about two of them, and primarily the ones I want to talk about is PVPP, which is polyvinyl polypyrrolidone, and say that 5 times fast, and Kieselsol, which is also known as your colloidal silica, and activated carbon. But the two I want to focus on are PVPP and activated carbon. PVPP is amazing. It's awesome. It has a cross-linked rigid structure. You can buy it in different grades. Depending on, it works on hydrophobic bonding. So it depends on how big the pocket is that attaches to the phenolic. You can buy PVPP in different grades, and it can be very good at taking out very targeted compounds. It works quickly, it flocculates really well, and it settles to the bottom. It's mainly used in whites to reduce bitterness and browning. So typical rates of addition are 0.2 to 0.8 grams per liter, can be added as a batch. Again, mainly used in white wine production, but super easy to obtain. But do you want to add plastic to your wine? Upside is you have a really targeted fining agent. And sometimes you can just add it straight to the wine. And you've seen me use this a lot on press fraction of wines with high level of browning and bitterness. I use a lot in conjunction with flotation now, where I can come in with not only PVPP, but a little gelatin. Because in white juice, we don't care. We want to take out all the phenolics we can. We don't want a grippy wine. So we may add some PVPP, a little gelatin on the front end in juice, and float it up to the top. The downside is it removes low molecular weight phenolics, which is color and bitterness. So you're going to strip out color. That's a downside if you're using this in red wine. It's a powdery mess, and it's also an inhalation hazard. But here you can see what it did to our 2012 Summit View Cab. I can't wait to show you what it did to the cab from our estate vineyard. But I thought this was really interesting that we saw this huge drop in CD tannins. So these short, dusty, little tiny things just really kind of took care of it and really had very little effect on the other stuff. So this is a good fining agent to take out those small, bitter compounds. Okay. Finally, when everything goes wrong, you have carbon. It's made from coconut husks. Only 8 grams of activated carbon have a whole acre of surface area. So think about that. 1 gram, if you were to lay it flat out, has a whole entire acre of surface area. Activated carbon is the most aggressive fining agent there is. It works through adsorption, and it's non-selective. It doesn't care. It's an equal opportunity fining agent. It doesn't care what's in the wine. It doesn't care who you are. It doesn't care what you look like. It grabs you and pulls you to the bottom. And it's useful for removing everything from not only tannins, but to bad aromas and everything else. And its rate is 0.1 to the highest I've ever heard is 2.4 grams a liter. And the reason I have this picture over in the right-hand side is this is a former student who decided to fine his wine with carbon. He got some leftover Malbec and went to made some wine out of it, and then the wine got a little funky because he made it in a 60-gallon barrel that had something else in it. He thought it smelled a little musty, so I gave him some fining agent ranges, and he decided not to pay attention to me and got on a homebrew forum and looked up the rate that he would add. And so he went ahead and, according to this homebrew forum, added about 30 grams per liter of carbon to the wine. And in that instance, it stripped the wine completely out. And he came in with this gray, sappy liquid. And he said, "Tim, what happened to my Malbec?" And I said, "Well, what'd you do?" He goes, "Well, I added based on what I saw in a homebrew forum." All right, guys, let's have a conversation. You are at the top 2 or 3% of all people in the US that know about how to make wine. Now, I'm not trying to blow smoke up your katukas, but if you are on a homebrew forum, you are the moderator. You are the person who knows more than anybody else. If you are on a home winemaking forum, you know more than most people. Now, obviously, there are going to be some UC Davis grads and some other people like me that have been out in the industry for a long time, but don't go on a homebrew forum, accept fining agent recommendations, and fine your wine with it because you'll end up with a gray, sappy liquid. But it was really fascinating because it tasted like a martini. Anyway, so carbon, treat with caution. Okay, so the upside to activated carbon is it strips everything. It is an egalitarian. It doesn't care who you are. It doesn't care what you do. You just strip it out. You can just add the wine, the fining agent straight to the wine, and it will settle out. It works well on moldy wines. The best place for carbon is on botrytized wines, wines that have botrytis in it, because it can not only work on just the things that are being created, all the lactases and other things, it can grab some of these phenolics and everything else, and it's really good to strip out wine. So if you're working in a place with high rot, carbon can be a great tool for you. In Walla Walla, probably not so much. The downside is it strips everything. It's not selective. It'll turn Malbec into light vodka, and it is so messy. It is so messy. And I thought this was really fun, where we added half a gram a liter to our Summit View Cab, and voila, boom, it stripped everything out. Catechin, polymeric anthocyanins, tannin, and we took this beautiful, robust, powerful Cabernet and turned it into rosé, basically. So that's what carbon can do for you. Last thing I want to talk about is colloidal silica. Basically, the only reason you use this is to counterfine a proteinaceous fining agent. So look at a manufacturer and find out what they recommend. Because what this does is you throw in your gelatin, you throw in your albumin, you throw in your isinglass, let it do its fining, and then you add a little colloidal silica, and it will grab on to whatever's left and settle it out to reduce your lees. That's all there is to it. If you add a proteinaceous fining agent, look into using colloidal silica to settle it out. That is it. So this is that idea of counterfining. If you're going to add a whole bunch of something, of a proteinaceous fining agent, you're going to have to settle it out. Again, I don't want to go through any specific details. Every manufacturer these days has different rules. And so just consult whatever enological gelatin or proteinaceous fining agent manufacturer you have. Consult with them, and they'll walk you through the process, what's going to work best for their product. But it is a good idea to always counterfine because it'll precipitate all the tannins and the protein tannin complexes. So here's a quick look at this study we did with the 2012 Summit View Cab. And so here's our control wine. And we go ahead and add some casein. It doesn't make a whole lot of difference. We saw a little bit of a bump in catechin. I don't think that was really a change. I think we just unmasked some of it. We had a little isinglass, and that had a bit of an effect. It softened the wine a little bit. And then we had PVPP, and look at PVPP. That just takes out all those small, tiny phenolics. Really good at taking those out. And you can see that reduces that bitterness component. And then albumin comes along, and it's not really good at taking out those things, but man, it's good at taking out total tannin. So one of the things I always thought was really interesting about albumin, it takes out all the big chunky tannins, grabs them and pulls them out. And this is something we've been doing as a course of action for millennia in Bordeaux. And maybe those wines were so green and tannic and sappy that this is what it took to get them consumable. And then here's gelatin, again, very similar in shape to the albumin in terms of its reduction of tannin compounds, but just definitely a little bit more aggressive than albumin. And here we come in for carbon, and carbon comes in for the kill. And if you want to strip a wine all the way down to nothing, carbon can do that. And so that's the nuclear option. But it's important to trial them, and I think it'll be fun for you to try a wine treated at a fairly low rate across the board to see how that affects the wine. And so this is sort of a comparative look at certain fining agents in a particular wine, but don't think that every wine acts the same. They're all going to be different. These are all tools that you can use to bat phenolics around. There is no right answer. There is no wrong answer. The thing is if you come across a problem wine, you've got to start thinking about ways that you can work on it. So if you have a wine that's too astringent or too unpleasant or something about it just doesn't strike you as right, these are some tools that you have. However, many of these things have gone by the wayside. Wine fining is probably becoming less and less important, except for on white wines. I think we're seeing that become more and more important in terms of flotation. But in terms of red wines, we're figuring out how to manage our phenolics on the front end. This is an antiquated thought. As we're moving down the road, we're doing better in the vineyard to create the phenolics that we want. We know how to extract the phenolics that we want on the crush pad, and then we also know how to modify them using micro-oxygenation and oxygen management prior to the wine getting barreled down. So we know better these days how to work up front. And I'm going to tell you this over and over again. If you work really hard on the crush pad, if you work really hard in the vineyard to create all of the right things, you don't have to create you don't have to use these things on the back end. You don't have to come in and start finding and fixing problems. However, if you find yourself working at some giant bulk wine facility or you're buying bulk wine, you might buy some junk that nobody cared about. And then in this case, you might want to be able to use fining agents to fix up some wines that just aren't doing so good. You got some brown wine, use some casein to clean it up. You got some wine that's just completely massive and clunky and sour and bitter and everything else. Go ahead and come in with some carbon and clean it out and make yourself a nice rosé. Rebuild it. You can buy color now. You can buy all the aromatic compounds and you can make an engineered beverage in a way that you can put it in a can for people to drink and enjoy. So I think some of these stricter rules of fining agents are sort of backing off because it's just not something we have to do anymore to hit a style point. So I welcome your conversation as we move forward. I look forward to talking to you about this as you taste through your fining trials. They're a bit interesting. I dialed back the amount a bit. So hopefully we'll see if the Cabernet from our vineyard has some positive benefit. Thanks.